Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of simple numerical problems on loaded DC generators of different configurations. By solving these problems, we shall learn how to determine generated EMF and currents flowing through different windings of a DC generator. Let us have a look at the equations we are going to use today to solve the numerical problems. In series generators, field winding is connected in series with the armature winding. The generator is loaded with a resistive load of resistance RL. Let the currents flowing through armature winding, series field winding and load be IA, IAC and IL respectively. Armature current IA equals to IAC equals to IL. Applying Kirchhoff's voltage law to this loop, we get expression for generated EMF E equals to V plus IAC RAC plus IARA plus twice VB, where V is the terminal voltage, VB is the contact drop per brush and RAC and RA are resistances of series field and armature windings respectively. Since IA equals to IAC, E equals to V plus IA times RAC plus RA plus twice VB. In shunt generators, field winding is connected in parallel with the armature winding. The generator is loaded with a resistive load of resistance RL. Let the currents flowing through the armature winding, shunt field winding and load be IA, ISH and IL respectively. Armature current IA equals to ISH plus IL. Here field current ISH equals to V by RSH, where V is the terminal voltage and RSH is the resistance of shunt field winding. Applying Kirchhoff's voltage law to the output loop, we get expression for generated EMF E equals to V plus IARA plus twice VB, where RA is the resistance of armature winding and VB is the contact drop per brush. A compound DC generator has two field windings. One is series field winding and another is shunt field winding. In long shunt DC generators, series field winding is connected in series with the armature winding. The shunt field winding is connected in parallel with the series combination. A resistive load of resistance RL is connected to the output. Let the currents flowing through armature winding, series field winding, shunt field winding and load be IA, IAC, ISH and IL respectively. Here shunt field current ISH equals to V by RSH, where RSH is the resistance of shunt field winding and V is the terminal voltage. Since armature and series field windings are connected in series, series field current IAC equals to IA. Armature current IA equals to IAC equals to ISH plus IL. Applying Kirchhoff's voltage law to the output loop, we get expression for generated EMF E equals to V plus IARA plus IAC RAC plus twice VB, where RA and RAC are resistances of armature and series field windings and VB is the contact drop per brush. In short shunt generators, shunt field winding is connected in parallel with the armature winding. With this parallel combination, series field winding is connected in series. The generator is loaded with a resistive load of resistance RL. Here series field current IAC equals to IL. Shunt field current ISH equals to V plus VAC divided by RSH, where V is the terminal voltage, VAC is the voltage drop across series field winding due to series field current IAC, and RSH is the resistance of shunt field winding. Therefore, ISH equals to V plus IAC RAC divided by RSH, where RAC is the resistance of series field winding. Armature current IA equals to ISH plus IL. Applying Kirchhoff's voltage law to the output loop, we get expression for generated EMF E equals to V plus IARA plus IAC-RAC plus twice VB, where RA is the resistance of armature winding and VB is the contact drop per brush. Problem number 1. A series DC generator supplies 50 ampere at a terminal voltage of 400 volts. The armature resistance is 0.05 ohm and series field resistance is 0.04 ohm. Taking brush contact drop of 1 volt per brush, we have to determine the generated EMF. Let us first jot down the given data. Terminal voltage V equals to 400 volts. Series field resistance RAC equals to 0.04 ohm. Armature resistance RA equals to 0.05 ohm. Contact drop per brush VB equals to 1 volt. Given load current IL equals to 50 ampere. Here series field current IAC equals to IL, that is equal to 50 ampere. Now we shall calculate series field voltage drop. VAC equals to IAC into RAC. Using values we get 50 into 0.04, that gives us 2 volts. In series generator, armature and series field windings are connected in series. Therefore, armature current IA equals to IAC equals to 50 ampere. Applying Kirchhoff's voltage law to this loop, we get generated EMF E equals to V plus VAC plus IARA plus twice VB. Using values we get 400 plus 2 plus 50 into 0.05 plus 2 into 1, that gives us 406.5 volts. Problem number 2. A DC shunt generator has an induced voltage of 254 volts. When the machine is loaded, the terminal voltage drops down to 240 volts. Neglecting armature reaction, we have to determine the load current if field and armature resistances are 24 ohm and 0.04 ohm respectively. Let us now jot down the given data. Induced voltage E equals to 254 volts. Terminal voltage V equals to 240 volts. Given Field resistance RSH equals to 24 ohm. Armature resistance RA equals to 0.04 ohm. Applying Kirchhoff's voltage law to the output loop, we get expression for generated EMF E equals to V plus IARA plus twice VB. Neglecting brush contact drop, we get expression for armature current IA equals to E minus V divided by RA. Using values, we get 254 minus 240 divided by 0.04, that gives us 350 ampere. Now we shall calculate field current. ISH equals to V by RSH, that is equal to 240 divided by 24, that gives us 10 ampere. Now we shall determine load current. IL equals to IA minus ISH. Using values, we get 350 minus 10, that gives us 340 ampere. Problem number 3. A 4-pole DC shunt generator with lap connected armature has field and armature resistances of 50 ohm and 0.1 ohm respectively. It supplies power to 60 100 volt 40 watt lamps. We have to determine the total armature current per path and the generated EMF, allowing a contact drop of 1 volt per brush. Let us first jot down the given data. Number of poles P equals to 4. Terminal voltage V equals to 100 volts. Number of lamps N equals to 60. Lamp rating PL equals to 40 watt. Given field resistance RSH equals to 50 ohm. Armature resistance RA equals to 0.1 ohm. Contact drop per brush VB equals to 1 volt. Let us first calculate lamp current. I equals to PL divided by V, that is equal to 40 divided by 100, that gives us 0.4 ampere. Total load current will be IL equals to N times I, that is equal to 60 into 0.4, that gives us 24 ampere. Now we shall calculate field current. ISH equals to V by RSH. Using values, we get 100 divided by 50, that gives us 2 ampere. For DC shunt generator, armature current IA equals to ISH plus IL, that is equal to 2 plus 24, that gives us 26 ampere. For lap connected armature, number of parallel paths A equals to P, that is equal to 4 for this generator. Armature current per parallel path equals to IA divided by A, that is equal to 26 divided by 4, that gives us 6.5 ampere. Applying Kirchhoff's voltage law to the output loop, we get generated EMF E equals to V plus IARA plus 2VB. Using values, we get 100 plus 26 into 0.1 plus 2 into 1, that gives us 104.6 volts. Problem number 4. A 4-pole long shunt DC generator with lag connected armature supplies 25 kilowatt at a terminal voltage of 500 volt. The armature resistance is 0.03 ohm, series field resistance is 0.04 ohm, and the shunt field resistance is 200 ohm. Taking a contact drop of 1 volt per brush, we have to determine the generated EMF. Let us first jot down the given data. Terminal voltage V equals to 500 volts. Output power PO equals to 25 kilowatt. Given shunt field resistance RSH equals to 200 ohm. Series field resistance RAC equals to 0.04 ohm. Armature resistance RA equals to 0.03 ohm. Contact drop per brush VB equals to 1 volt. Let us first calculate load current. IL equals to PO divided by V. Using values we get 25 into 10 to the power 3 divided by 500, that gives us 50 ampere. Now we shall calculate shunt field current. ISH equals to V by RSH, that is equal to 500 divided by 200, that gives us 2.5 ampere. Now we shall calculate armature current. IA equals to ISH plus IL. Using values we get 50 plus 2.5, that gives us 52.5 ampere. Since series field and armature windings are connected in series, series field current ISC equals to IA, that is equal to 52.5 ampere. Applying Kirchhoff's voltage law to the output loop, we get expression for generated EMF E equals to V plus IARA plus IAC RAC plus twice VB. Using values we get 500 plus 52.5 into 0.03 plus 52.5 into 0.04 plus 2 into 1, that gives us 505.675 volt. Problem number 5. A 4-pole short shunt compound DC generator supplies 80 ampere at a terminal voltage of 200 volts. The armature resistance is 0.04 ohm, series field resistance is 0.02 ohm, and the shunt field resistance is 40 ohm. Taking a contact drop of 1 volt per brush, we have to determine the generated EMF. Let us first jot down the given data. Terminal voltage V equals to 200 volts. Shunt field resistance RSH equals to 40 ohm. Series field resistance RAC equals to 0.02 ohm. Armature resistance RA equals to 0.04 ohm. Contact drop per brush VB equals to 1 volt. Given load current IL equals to 80 ampere. Here series field current IAC equals to IL, that is equal to 80 ampere. Now we shall calculate series field voltage drop. VAC equals to IAC into RAC. Using values, we get 80 into 0.02, that gives us 1.6 volt. Now we shall calculate shunt field current. ISH equals to V plus VAC divided by RSH. Using values, we get 200 plus 1.6 divided by 40, that gives us 5.04 ampere. Now we shall calculate armature current. IA equals to ISH plus IL. Using values, we get 5.04 plus 80, that gives us 85.04 ampere. Applying Kirchhoff's voltage law to the output loop, we get generated EMF E equals to V plus VAC plus IARA plus twice VB. Using values, we get 200 plus 1.6 plus 85.04 into 0.04 plus 2 into 1, that gives us 207 volts. So today we have solved a couple of simple numerical problems on loaded DC generators of different configurations. By solving these problems, we have learned how to determine generated EMF, currents flowing through different windings, and load current of a DC generator. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.